Okay. So support vector regression. Okay. What is support vector regression? Support vector regression SVR trains using a symmetrical loss function, which equally penalizes high and low misestimate. Using Wapnick's E-insensitive approach, a flexible tube of minimal radius is formed symmetrically around the estimated function such that the absolute value of errors less than a certain threshold are ignored both above and below the estimate. In this manner, points outside the tube are penalized, but those within the tube, either above or below the function, receive no penalty. Okay, a very simple one. We'll see what is this saying here. So let me. Okay, so here, this one is our normal regression. Okay, so normal regression, when we saw that there were some points which were here, some points which were here. Okay, some point. These are all errors. Okay, this is our actual trained one. After training, all our points should ideally fall in this dotted line. Okay, red line. But there will be some errors. Okay, these are all errors. Okay, and when you take the ordinary least square, okay, when you take this is the final expression which we get. But in this case, support vector regression, we will create a tube. Okay, and the function of the tube is this tube. What it will do is the points which will fall inside this tube, there will be we will be excusing them of the errors. Okay, especially in our video exams, I don't know whether it is now applicable now, but people who are getting marks like 30, see 35 was pass mark during our time, and those who are getting 33, 34, generally they were giving grace marks, so that they will be passed. Okay, so similar to that yellow mark is that thing. Okay, the students who are getting just almost near to passing mark, we will consider them as pass. So that was the thing here. Okay, so here this yellow thing was the same concept here. The above one are the outside that maybe 32, 31. Those people are considered as only failures. And this is how. See, these are the points which are considered only. Okay, these points which are actually errors are no longer considered as errors. Okay, only these points which are outside are considered as errors. So now how to implement this next step. Okay, so this is straightforward. There is only one small change which is there. Okay, no, two changes are there. Let us see what are those. See, data set I am taking the same. Okay, now this data set here, what will be this data? It is a 1D data. What is this data? This is 2D data. Why? Just I'll show you once before going above. No, see, this one is coming in two brackets. Okay, you can see there is one bracket for this data and one bracket outside. Okay, this data is having only one bracket. Okay, so this is two-dimensional data. This is one dimensional data. Okay. Now that data was used for all our previous cases, but our SVR requires that data to be in different form. Okay. So what we are doing is we are reshaping this Y. Okay. Using pandas option. Okay. That is m y dot reshape. Then what we get is you can see this 1D data has now become 2D. Okay. This is the 2D data. Now, why we had to do this? Because we had to do some transformation here. Okay, what is this transformation? I will explain. Transformation is exactly similar to your GPS system. Okay, so what they do in GPS system? If everyone has scored 80, 70, and whoever has scored highest, they will divide that number with highest by divided by with all the other numbers. Okay, and then everyone's number will now be less than 1. Okay, so that is how GPS system will work, right? So something similar to that will be done here, where we are normalizing things so that the bigger numbers will become smaller. Okay, so here position scalar salaries. So these numbers are in thousands and all, right? This is also a huge number for this SVR. So SVR can understand smaller numbers. So it's like dividing this divided by one the highest number, you will get small, no? Similar, something similar to that is done here, where we are using standard scalar function to, and we are using this two different standard scalars. So two objects are created here, and then we are passing this x and this y, and finally what we get is the scale normalized data. Let us see how the normalized data will look. Okay, so this is your data. This data has become normalized now. Okay, this 1 to 10 has become this, and this 45,000 to 10, 80, 1 crore has become this. Okay, these are the two data which we have got now. Now, this data is actually our x and y only. Okay, but it will look different. But our why we need that is this SVR is a unique case which cannot work in big data. Okay, so we need to convert them into smaller form by doing this transformation. If we do that, then there is no other change. Okay, this regressor dot fit, we are passing this kernel and we are running it. Okay, now when we predict the data also, we must use this regressor dot predict and sch dot transform, so that 6.5 will become this, and we have to also do inverse transform. Okay, if we don't do inverse transform, see, this is our actual data, okay, which we want to do it, but we also want to do this inverse transform, so that or else we will not be able to understand what is the value. Okay, see, if we just give you this number, if you get a result back in this form, if you get the result back in this form, we will not be able to understand what is the salary. So we will do a inverse transform also here. This is the inverse transform, this is our normal prediction. Okay, that is how we are doing. Now let us visualize the SVR result. Okay, this is the So this is how our data will look. Okay, SVR also will generate similar plot. Okay, but it will look something like this. You will not see the tube and all, but it has done that internally. Okay, this is the data. This is a similar plot but with higher resolution. What is higher resolution? I'll tell you. First, we'll see the visualize the data. There will be a small change. Okay. So this is higher resolution. You can see the points are very close by, so you get a very fine finish. Okay. How to get that higher resolution? So here what we do, instead of I'll explain that in data form. Okay. Instead of 1 to 2, what we do, we will do 1, 1.01, 1.02, 1.03, 1.04, like that up to 2. Then between 2 to 3, 2.01, 2.02, like that. So we will increase the number of points. Correspondingly, we increase the salary, okay, with that same factor. So all the points will be considered here, and then we are passing the data to the same formula. Okay, formulas are simple. Instead of 10 points, now we will have 10,000 points. So we will get higher resolution. So here X grid. What is this X grid? Min of inverse transform and max of inverse transform. So min number and max number will take. Then in steps of point 1 we are going there and we are increasing the values. Okay. So we will get higher resolution. So you can run this, understand. If you don't understand any part, okay, out of this, you can just message in the chat, sir, I did not understand importing the data set, I did not understand feature scaling, I did not understand visualizing the SVR. You can just put it in the chat. First, for 10 minutes you can run all the part of the code. Okay, whichever part you did not understand, you can also just copy paste that line in the chat. I will check. Okay, now I will be sharing this code in the mail. Okay, so I think yesterday some student had doubt. I will check that one. So I think Akshay had some doubt. Let me open that mail and I'll check once. I will pause. Okay. Hopefully, see. If you don't understand, just message me. Which part? So since we have already done so many things, you now I cannot explain fully. So just explain. You can put it in the chat. Which part is not clear? I will explain that part. Okay. You can just drop that in chat if you have any doubt, or else I'm continuing with the topic. Okay. Okay. So now we are done with SVR. Okay, so next one is a very interesting one, decision tree regression. Okay, what is decision tree regression? It will take decisions. It is actually one of the classification program. Okay, so where we are doing classification, and classification is generally dividing things in groups. So it is coming from there, but it is also used in regression. Okay, so what is this? This is your data. Okay, so we can group this data. So what we will do, we will take one group. First we'll do, imagine that these other splits were not there. This was your complete data. Okay, there are no split. Then first you will do one split, one big split you will do. Okay, then you will do second split here. Okay, then you will do third split. Then you will do fourth split. Okay, now this is your final data. Okay, then you will make this, call this as group 1. This is 2, 3, 4 and 5. Okay, you will make that as 2, 5 these groups. Now once you have done this grouping, then finally what you will do, you will take the average of all these numbers. Okay, you will take only this group, take the average, take this group, take the average, take this group, take the average, take this group, take the average. Finally you take all the groups, you will take average. Now once a new point will come here. Okay, wait, what is- now if a new point which is somewhere here comes, then this new point will be given a value of 65.7. Okay, and if a new point comes here somewhere in at this corner, okay, this value, the predicted value will be given as 300.5, and if a new point falls here, that will be given 64.1. Okay, so there will be accuracy will be less here. Why? Because any point in this group, if the groups are made very big, right, then what will happen, it will take all the points as 64, so the accuracy will come down drastically in this case. Whereas here zero point 0.7, the accuracy will be higher. Okay, sorry, here also it will be low. Okay, so this particular algorithm, if the point lies far away, then the averaging will reduce the prediction value. Okay, but if a linear regression is somewhat like this. Okay, um, okay, so if the regression is very much random, okay, so it is falling here, 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 then SVR will be the, it will be better for this kind of data. Okay, you can try implementing that. Sorry, not SVR, uh, decision tree regression. Now let us see with our data set. Okay, decision tree regression with our data set. This is a very simple one. Only you have to change this name here, decision tree regression. That's it. Okay, over. Then you can just do plotting and visualizing. Position salaries. This one. This is the 3 lines which we should add for decision tree regressor. Regressor dot fit. That's it. No other change. So this regression is straightforward. Now if I run this, this regressor works in a different way. Okay, now I'll explain this plot. Okay, so here this is called decision here. Okay, so any number which will fall in this range, you will be given this value. Any number which will fall in this range, you will be given this value. So it will not, it will be like 1 and 0. Within a range it will be like 1 and 0. Within a range it will be like 1 and 0. It will not think much. Okay, So it will be like a true or false kind of thing within this range. Okay. So if you see the predicted output, you will get a better understanding. So it has predicted one value also 50,000. Okay, for 9.5 years. So a person with the 9.5 years of experience. So let us see the data. So for 9.5, between 9 and 10, 9.5 it has considered 50,000. It should have actually given a value in between this. Okay, but it will act like true or false. If it was 9.6, it would have given 10,000. Okay, 10 lakh. It is 5 lakh. Okay, sea level. So for between 9 and 9.5, it is dividing it into two groups. One is 9 group and one is 10 group. Okay, it is not thinking beyond that. So that is the problem with decision tree regression. But application for it, see, for one data, one algorithm will work. Another data, another algorithm work. So if everything was taken care by one algorithm, then there was no need of a machine learning data scientist engineer. Okay, so engineer's data is to see for which data which algorithm has to fit and what small tweaking you have to do so that the efficiency will increase. First part I have already explained. How to tweak small changes is the next step. I will explain that. First, what you have to do, run this code for decision tree regressor and check the output. Then I will explain the second part, which I told how to make small tweaks in the code so that efficiency will improve. Okay. First, I will share this. Today we will take this data and try. Okay, I will share it in the email. Okay, so I have done this part data. So now I'll just change this here data. Okay, data is done. Now I want only the first or zeroth column. Okay, zeroth column 80. So this colon step of 9. Simply I'm getting a big number so that I will get the first data only. Okay, the why I have done this so that I will get only the first column. Okay, now nothing else I have to change. Nothing else. So I think this one I have to comment because that is valid for position salaries. Okay, nothing else to change. And if I run this, now you get this kind of output. Okay, so it has taken so many decisions and it was predicted. Okay, so this is your actual data and this is the predicted data. Okay, now you can also give some input and check with how well it has predicted your results. Okay, so that also you can try. So something like this you can also do, but you have to give the actual data. This 9.5 is for your position salary. So what is the actual data is there? That one also you can give. Okay, if things are clear, we will meet on Tuesday. Okay. So now I think I will not go to the next topic again. So Today's assignment is, again you have to do all the analysis of data on, see, first step is, now we have multiple data sets, okay, position, salaries, data, and startups. So, and how many algorithms we have? Okay, so let me tell you. See, you have three data sets, okay, three data sets you have, and you have four algorithms. So, simple linear regression, multiple linear regression, polynomial regression, SVR, and today's data decision tree. Okay, so all this five, I guess five we have. So try to see how each data set reacts, okay, for all of these five algorithms, and then you should tell me, for data set 1, I am going to go with this algorithm. Data set 2, I am going to go with this particular algorithm. Data set 3, I am going to go with fifth algorithm. Maybe this is third algorithm. So for which data, which algorithm suits the best? You have to come up with that conclusion. Okay. So there is one more algorithm in linear regression. I don't want to rush. That's why. Okay. Do this thing. You have time. So let us meet on Tuesday. Okay. And if you don't understand anything, you can message me in the in my WhatsApp group, WhatsApp thing. I will discuss that topic in the next class. Okay, I will not be explaining you one on one, but I will explain this in the class. Okay, whatever doubts you have, you guys can. If you find it difficult to ask here, you can do that later also. Okay.